All right, buffer overruns. Back to buffer overruns. I said state of knowledge up to 1996 was if you had a buffer overrun involving a buffer that was allocated on the stack, bad news. You're in trouble. At some point, a couple of years later, at that point in 1996, we thought if this buffer was allocated on the heap, you're probably okay. Attack can cause your program to crash, but they're not going to take control of it. But at some point after that, a few years later, bad guys started coming up with methods, and researchers discovered that our understanding was too limited. That in fact, if there's a buffer overrun involving a buffer that's stored on the heap, that's just as bad. There are more complicated ways that attackers can use to, again, inject malicious code into your application, start it executing, and take complete control of your application. So about as bad as could possibly be. So it's not just stack allocated buffers that are at risk, it's all buffers. A buffer overflow involving any buffer is really bad. And I can give you a sense of this by telling you a little bit about how C++ works and then how we exploit this. So if there's a buffer overflow in a heap allocated object, that means the attacker is going to be able to write bytes after that object. So we have to think about what's stored in the heap. And after that object will probably be another object. And how are objects stored in C++? C++ is object-oriented, so you have classes and subclasses. And to support that, the compiler puts, anytime you store an object in the heap, before the data of the object itself, there's a vtable pointer. And the vtable pointer records information basically related to the type of this object so that we'll know how to interpret what's in there. And the vtable pointer has, among other things, the vtable pointer is a pointer to a table, an array of pointers. One pointer per method in the class. And that is useful so that if we have a subclass, that shows up as a different vtable. There's a separate table for the subclass with a different set of pointers. So you can do method calls the same way. A method call to bar is look up the vtable pointer and look at the pointer in the first spot in the array and invoke that. And that'll work no matter whether we're talking foo or a subclass of foo. Okay, so what this means now is the way that attack works with a C++ program, the heap overflow, is that the attacker overwrites past the end of the buffer and starts overwriting the next thing in the heap. And the next thing will probably be a C++ object, and the C++ object starts with a vtable pointer. So the attacker overwrites the vtable pointer and overwrites that address with a new address. The attacker controls the data that's getting written there, so the attacker controls that new address and changes it to point to somewhere else in memory that the attacker controls. So now instead of making it point to code, the attacker makes it point to some data that has their own choice of vtable. And their own choice of vtable, those just contains addresses, will have an address in there that's the address of their malicious code. Okay, so now the attacker has to write not just malicious code into memory, they write a malicious vtable and malicious code, and then they overwrite the vtable pointer to point to their malicious vtable, and then they're off to the races. Okay, so heap overflows are just as bad. Use after free is also just as bad, another class of vulnerability. If you allocate an object and then you deallocate it, you free it, and then you go right to that object after it's been freed, that's a no-no. You're not supposed to do that, but it's also a security bug. Because what happens is the allocator will reuse freed memory. So if there's some other code that's run or if there's another thread and there was another allocation that happened, that freed memory might have been assigned to another object of a different type. And so when you write new data, you might be able to overwrite a vtable block. So if your code ever writes to an object after it's been freed, you will also have a security vulnerability akin to a buffer overflow.